Hello everyone, this is K. Sandhya Rani. In this video, I would like to discuss about Newton-Raphson formula and its procedure. So let us try to understand. Before starting with Newton-Raphson method, first let us try to understand some introduction part which involving this polynomial function and transcendental equation. So what is polynomial function? The polynomial function is nothing but some polynomial equation which is like the equation involving algebraic terms in it. Means a linear equation ax plus b is also called as polynomial function, and a quadratic expression ax square plus bx plus c is also called as polynomial function, and cubic one, that is ax cube plus bx square plus cx plus d, this is called as a cubic polynomial function. Okay, in the similar way, this is linear, this is quadratic, this is cubic, right? So these highest power terms are nothing but the degrees. This x power 1 is the highest power term in this expression, so this is called as a polynomial function with the degree 1. And here x square is the biggest power term, so this is called as a polynomial function with the degree 2. And here in this function, x cube is the biggest power term, so it is called as polynomial function with the degree 3. Similarly, in a generalized manner, if we try to take n number of constants like a0, a1, a2, a3, so on, an are the constants here, which behaves as the coefficients of all algebraic terms involving in the polynomial function. And here x power 1, x square, so on, x power n minus 1, xn be the algebraic terms. So the expression an x power n plus an minus 1 x power n minus 1 plus so on a2 x square plus a1 x power 1 a0 is called as polynomial function of degree n. So therefore the number an, whatever here we can see, the number an is called as coefficient of the highest powered term, and it is also called as leading coefficient of the polynomial function. The coefficient of the highest powered term in the polynomial function is called as leading coefficient. Okay, so after learning about this polynomial function, let us discuss about transcendental equations. What are these transcendental equations? A non-algebraic equation, non-algebraic means not only like this polynomial functions. In polynomial functions, what we have seen, purely algebraic terms are involved here with constants. So other than this algebraic terms, we have many other terms like trigonometric terms, logarithmic terms, exponential terms. If an equation containing all these different kinds of terms in it is called as transcendental equation. Simple logic. The equation containing all different kinds of terms like trigonometric, exponential, and logarithmic, algebraic altogether is called as transcendental equation. Here, if you see the definition, a non-algebraic equation is called as transcendental equation, which includes trigonometric, exponential, and logarithmic functions. And for a few examples, 2 sin x minus x. This is trigonometric term, this is algebraic term. The second example, e power x sin x. This is exponential, this is trigonometric, and this is algebraic. Third example, log x square minus 1, logarithmic term. Fourth example, x minus e power 1 by x. This is algebraic term, this is exponential term. Okay, so like this, an equation involving all different kinds of terms in it is called as transcendental equation. So after learning about this polynomial function and transcendental equation, now how to find out the solution of these two kinds of functions, polynomial equation and transcendental equation. So solving means finding the variable value in the equation. So irrespective of the kind of the equation, like polynomial or the transcendental, when the situation arises of solving the equation, what happens? We need to find out its respective roots, otherwise the value of the variable involving in the equation. So usually to find out the solution of transcendental equations, we have two different numerical methods in our chapter. What it is like, first one Newton-Raphson method, the second one is regular falsy method. So now we are going to discuss about Newton-Raphson method, whereas these two methods are the numerical methods. So what does this numerical methods mean? So in the process of finding the solution of the given transcendental equations, we are going to utilize some iterative methods and purely numerical calculation part. So this kind of procedure of solving the equation is always called as numerical methods. Doing numerical calculations by using some iterative formulae is called as numerical method. So first numerical method for solving transcendental equation is Newton-Raphson method. So let us try to understand what is iterative formula is going to be used in this procedure in Newton's method. First one. Here the formula is xn plus 1 is equals to xn minus f of xn by f dash of xn. Means if the given equation is of this kind, let us try to understand the formula. Before that, you see, suppose the given equation is like this: y is equals to 2 sin x. Okay, so considering the given equation as y is equals to f of x, we are going to have f of x in terms of x. Okay, and if we differentiate it, this is given, and after differentiating for one time, we are going to have f dash of x also, right? So later on what we are supposed to do is we need to utilize one for iterative formula. What we discussed is, so what does this iterative means? Iterative means continuously repeated. So what is going to be repeated? Certain formula is going to be repeated here. So what is that formula here? So that is nothing but our xn plus 1 is equals to xn minus f of xn divided by f dash of xn. Okay, so if you try to put x equals to 0, then what happens? X1 is equals to x naught minus f of x naught divided by f dash of x naught. Similarly, x2, if you put n is equals to 1, then what happens? X2 is equals to x1 minus f of x1 divided by f dash of x1. So what is happening here? See, repeatedly some formula is being repeated to find out successive values of x, like x1, x2 and x3, so on, isn't it? So this is called as iterative formula of Newton-Raphson method or simply Newton method. Okay. After knowing about this iterative formula, let us see how to solve a question. Means how to solve a transcendental equation by using this Newton-Raphson method. So here we have chosen a function y is equals to root of 28. Okay. They have given an equation x is equals to square root of 28. Fine. Right. So first let us try to simplify this. X is equals to square root of 28 is provided. So if we try to square on both sides, we are going to have x square is equals to 28. And this x square minus 28 is equals to 0. Okay. So now what we can consider, the function f of x is equals to x square minus 28 is the required function. Right. So for this function, means for this equation, we need to find out the solution. Means we need to find out the x value. So further, let us consider what is f of x. So according to our knowledge now, we have considered this f of x as x square minus 28. So if we differentiate it, we are going to have f dash of x is equals to 2x. Okay. So next what we are supposed to do means we need to identify an interval in which the root lies between. We need to estimate an interval. So before going to this, let me tell you some working rule, otherwise working procedure of this Newton-Raphson method. So in the first step, let us consider the given equation f of x and let us find out its first derivative f dash of x. In the second step, we need to estimate the interval where our root lies between. That is, x belongs to open interval a comma b. By putting 0, 1, 2, 3, so on values successively in the given function f of x. So somewhere at 2 successive substitutions, we are going to have the functional value in an opposite way. That is positive, that is negative. So those 2 successive values, whatever we have substituted to have opposite sign values, in that particular interval means when the root lies between those 2 successive values, and it should be denoted as like x will be lying between those 2 values. Okay, so like this, in the second step, we need to estimate the interval where the root lies between, means x lies between. So after that, we need to start calculation of iterations. Before that, you see, we need to consider x0 and x1. So in this continuous calculation of x value, we will be calculating x0, x1, x2, so on, right? Where these x0, x1, x2, so on are called as successive values of the root what we are calculating for in this method. So after by using iterative formula, we are going to calculate all the successive values of the root. Till where we need to calculate means until we get a repeated value. So whatever the repeated value we are getting, that repeated value will be considered as a solution of the given transcendental equation. Repeated value. Okay, repeated value becomes the required solution. So these are the few steps we are supposed to follow. So whereas iterative formula we have discussed like x1 is equals to x0 minus f of x0 divided by f dash of x1, and similarly for x2 and x3 also the iterative formula will get repeated. So now let us try to apply this working rule what we have discussed right now. So as per our discussion, the given equation is like here x square minus 28 is equals to 0, right? So therefore f of x we have considered as now x square minus 28. Okay, so f dash of x becomes what differentiation? That is 2x minus 0, that is 2x. So we need to estimate the interval, right? For that we need to find out f of 0 value, f of 1 value, f of 2 value, f of 3 value, and f of 4 value, f of 5 value, f of 6 value. Okay, so here f of 5 value is negative and f of 6 value is positive. So here at these two successive values of x, we are getting positive and negative values. So therefore, what we can say is the required root, nothing but x value, will be lying between 5 and 6. Means the x belongs to the interval 5, 6. So like this second step also we did. The root lies between 5, 6. After getting this interval, whatever the first value in this interval will be there will be considered as x0. This is called as first approximation. Why? Because now only we are telling that the root lies between 5 and 6. So it may be 5 also. So assuming that it may be 5 also, let us consider the first approximation as x0 is equals to 5. So immediately to calculate the next approximation x1, we require certain values like f of x0 and f dash of x0. Those should be calculated first. Why? Because already we have f of x and f dash of x. By putting this x0 in these two functions, we are going to have f of x0 and f dash of x0. This is f dash of x0. Okay, so after getting this, the second approximation like x1 is equals to x0 minus f of x0 divided by f dash of x0 should be calculated, which we got it as 5.300. This is called as first approximation. In the second approximation, we are going to find out x2. What is this x2 formula? x1 minus f of x1 divided by f dash of x1. Okay, so in this we can see the terms x1. x1 is already calculated now, 5.300, and f of x1. F of x1 also calculated here, f dash of x1 also calculated here, 10.60. So let us put these three values along with all these three, x1 and f of x1, f dash of x1 in the formula, so that we got x2 value as 5.2915. Okay. In the third approximation, here after getting second approximation, we need to check whether first approximation value and second approximation value are repeated decimals or not. So how can we estimate this repeated one after the decimal of 2 digits are being seen? Then we can consider that as an approximate root of this given transcendental equation. So here we got 5.330. Here 5.29. So both are different. So let us move on for the next iteration, that is calculation of x3, that is third approximation. So before that, the information required for the calculation of x3 is x2, f of x2 and f dash of x2. So x2 we have calculated, f of x2 we have calculated, f dash of x2 also we calculated. Let us put all these three, and by using calculator, let us find out what is x2 here. What is x2? 5.291502 we got. If you observe the second approximation and third approximation, 5.29, 5.29. So after the decimal, 2 decimals, not 3 decimals are being repeated. 291, 291. So we can stop calculating the approximations here, and this repeated value can be considered as approximate root of the given transcendental equation x square minus 28. So this repeated value, that is 5.291502, will be considered as a final root of the given transcendental equation. Okay, so what we have done, first we have simplified the function if it is required. Yes, we did it. And later on, we have estimated the interval where the root lies between, that is 5 and 6, by substituting all the values successively in the function, where the two successive values 5 and 6 gives positive and negative values. So therefore, we are saying that the root lies between 5 and 6. Thereafter, this 5 is considered as the first approximation x0, and we have calculated x1. Repeatedly, we calculated it as x2 and x3 in the second and third approximations, and we got second and third approximations as repeated values. So that repeated value is our final answer. That is a approximate solution of this given transcendental equation. So like this, we are supposed to solve the given transcendental equation by using Newton-Raphson method. So like this, the Newton-Raphson method will be utilized for finding the approximate solution of the given transcendental equation. So in this, we have completed the transcendental, we have completed Newton-Raphson method.